חלק מהצוות הנפלא שמארגן פה מיטאפים. כולם פה בלבד? אני לא צריך להציג את עצמי. אתם יודעים שאנחנו משקיעים הרבה בכל העולם של המובייל, ויש לנו צוותי פיתוח גם בארץ וגם בחו"ל. וכל הנושא הזה זה מאוד מעניין אותנו וחשוב לנו, אז אנחנו היום הזמנו אורח מבחוץ, מאיביי, שיש לו איזה נושא מאוד מאוד מעניין בתחום של מובייל, איך להרצות לנו על זה.
I'm going to present in English. I hope it's okay with everyone. My name is Benny. I'm actually now from PayPal, from the Consumer Product Center in Tel Aviv. But up until a month ago, we were the Israel Innovation Center of eBay in Tel Aviv. So I want to share with you a story I had while we were developing our latest mobile application. It was the iPhone application, and we were nearing the release date. And my product manager, Matan, had a bunch of content changes, text and images that needed to be made in the application. And I was in charge of implementing those changes. And once such change was, for instance, to change the title of the home screen from my activity to my recent activity. So that's no problem for me as a developer. It's just a text. I change it, but now the title breaks into 2 lines. OK, I go back to the product manager, to Matan, and I tell him, listen, this is how it's going to look from now on. So we go to the designer, Adi, and Adi says, no. We can't break the line into 2. It breaks the whole design paradigm. It has to be 1 line. You have to change the text. But now there's a problem because we have to consult the marketing manager who gave us the text to change in the first place, and also the legal advisor. And there's a whole circle of people that need to be involved for every change. And if there are problems on the way, then each cycle can take even a few days, especially if you work overseas with another team across the Atlantic. And I call this the circle of inefficiency. And maybe there's not much you can do about it because you can't have all the people in the same room all the time making the decisions together. But I felt as a developer that maybe my role in this is pretty mundane and minuscule, right? I just change texts. It's not really programming. It's just changing things and waiting for input. I don't want to do it. I'm not part of the decision-making process. So I want to be here, right? They can make all the decisions they want. And at the end, come to me, and I'll make the changes in code. That's OK. And we already have this development paradigm in web development, right? In web pages, anyone can go to a web page, open a developer tools, and change what they want. I'm going to show just a little demo of what I mean. Let's go to LivePerson's website. And let's say the marketing wants to change the title. So you open the DevTools, you find the text you want to change. Voila, or whatever it is. And now you can take a screenshot, show it to the designer, and get approval or not. And a developer doesn't need to be involved in that phase. Only at the end, he needs to be involved, and even then, maybe not. So I'll go back to the slides. So I set out to, in mobile, we don't have this, right? Because you can't change the mobile application at runtime. You have to change the code or the content, and then recompile and reinstall on the device. It's not as easy as it is on web. But I thought maybe there is some kind of tool or plugin that can help me do that, or help the designers do that. And I set out to find some kind of tool. I found some interesting solutions, but none of which really satisfied all the requirements I had. And I categorized them into 3 categories of solutions. One is Mac applications. So we have the Reveal app. I don't know if you're familiar with it, but any iOS developer should get familiar with Reveal. It's a really cool tool for debugging. The way it works is you launch Reveal on your computer. You launch your application on the simulator or on your device on the same Wi-Fi network. And then you have your device, your application's content is being mirrored to the Reveal application. Of course, you have to install the Reveal SDK in your application for this to work. And in this example here, we see that how in the Reveal application, we are changing the text alignment in the Reveal, and this is being reflected on the device at runtime. So you can make changes like you do on web. The Spark inspector I didn't test, but it's supposed to be the same by their website. There's a few disadvantages to both of them. First, it's a Mac-only application, so if your designer works with a different machine, then she can't even install the application. It costs money. Reveal costs $180 per developer, Spark $50. Maybe that's not a problem if you're working in a big corporation. You have to be in the same Wi-Fi network, so if your device is on 3G, it doesn't work. And the interface is a bit cumbersome, as you can see here. It's not very intuitive or fun. It feels like working too much. So that's the Mac app. Next, we have native plugins. We have the Facebook Tweaks and the Flipboard Flex. And they are both plugins you can install, or pods you can install in your iOS application. And in Facebook Tweaks, it gives you macros. You can you write a macro instead of a variable in your code, and that macro produces a variable you can use in code. And then if you take your device and shake it, a secret menu pops up, like you see here. Imagine it shakes, and this is a secret menu. And then you can change the variable, the value of the variable. In this case, they changed the color from black to blue. The disadvantage here is that you need to mark all the variables you would want to change in advance. So if you, let's say if you want to make your whole application flexible, you have to do your whole application in the flex macros, and that's a big no-no. Flipboard is more robust. You don't have to mark in advance anything. You have to supply a way to pop up a menu. This animation will roll, and you'll see the menu. And from that menu, you can choose whatever UI element you want, and then you can change any attribute of that UI element. Here, I think they're changing the color or the text. And that's great. That's closer to the solution I was looking for. But if you're dealing with a lot of with texts, then it's not convenient to edit text on the device itself. You want to do it from a computer with a real keyboard. And also, you have to do a bit of configuration here in order to load the flex menu and unload it. That's the flex menu here. Next set of solutions are A/B testing frameworks. A/B testing frameworks like Aptimize and Optimizely, it's actually a web application. You install their SDK on your device, and then you go to the website, and they both provide something they call a visual editor. And in this visual editor, you see a mirror of your application's interface. Like here, this is a real device, and this is a mirror of that UI. And then you can change on the browser, you can change the UI, and it changes on the device. And that's really close to what I was looking for. Only this solution is it's one feature of the A/B testing framework. What they specialize is in A/B testing and not in content changing on the device. So it's not their main feature. Also, it's a third-party server. So if you're using it, you're streaming all of your application's content to a third-party server. And that may be something you don't want to do, especially if it's a banking application or something that you want to keep to yourself during development. And also, it's closed. It's not open source, so you can't see what's happening inside. For instance, they don't support dialogues. So if you have a dialogue in your application and you want to edit the text in the dialogue to see how it looks like, you can't do it. And you can't also change it, because you don't have control on the code, and you can't add features or fix bugs if there are any. And of course, it also costs money to use. So I didn't find the thing I was looking for. I wanted it to be, there was a set of requirements I had in my head that the solution had to adhere to, and had to be easy and fun to use. It had to be easy to install with no configuration, because I was thinking about other developers that might want to try the solution. And it had to be very easy in order to try. And all of the previous solutions you had to do some legwork in order for it to work. And I wanted it to be free and open source as well, so other developers can contribute and do whatever they want with it. And so I built it. I didn't find it, so I built it. I called it the tool BetterContent, and I want to tell you how I built it after I told you why I built it. And I'll start by showing you a demo of how it works. So I'm going to launch, this is an Apple sample project, and I installed BetterContent on it. And now I'm going to launch the BetterContent server. So what we see here is the web page is mirroring the application. Let's navigate a bit. So whatever happens in the application also happens on the web. And the cool thing is on the web here, I can change the text of whatever I want. No, it doesn't support 2 lines. Anyone in the audience want to try, if you have a computer, just to see that I'm not hacking you? Maybe you there?
Sure.
Go ahead and head over to, oh, just a second. Where is it? Sorry. BetterContent.herokuapp.com.
This is Mac only?
So we're dealing with iOS applications. And here I have the simulator, which runs the application. But you can launch BetterContent.herokuapp.com from whatever computer you want, just a browser from a tablet. Let me know. Here we have. So you're doing the changes, right?
Yeah.
Right. So it works.
Can you change pictures or move
So currently, I've only implemented the ability to edit text, but so no pictures yet. But it shouldn't be a problem. Optimizely has it. It's a matter of loading a picture on the web, serializing it to base 64, and then sending it via JSON to the client. Not that big of a problem. OK, so the powerful thing here, and this also works on a real device, only I couldn't show you a real device because it'll be too small. And also, this is being recorded, so it wouldn't show on the recording. But the powerful thing is, this is pretty simple. I mean, this guy here did it in, well, he's a developer, right? But I mean, anyone can edit on a web interface. It's really easy, and you can just give your application to the designer and tell them, OK, whatever changes you want to test, go around. This is your playground. Play, and let me know if you want any changes made. And you don't have to be, I mean, myself as a developer, we don't have to be part of all this playing around that's inherent in mobile applications because of you can change it once it's the application runs. OK, so I also prepared a video of the demo in case it doesn't work, but it did work, so no need. So I'm going to delve a little bit into how I developed BetterContent. So at first, I didn't want to do a whole lot of developing. I wanted it to be easy. And I thought maybe I can only do the native part and find some kind of web service that I can use in order that other people can edit the content at runtime. And I thought about Google Spreadsheets. So in my vision, I had the application run, spew all of its content, all of its text content to a spreadsheet. And then the designer would edit the text in the spreadsheet, and that would be mirrored back into the application. A couple of problems. First is that Google Spreadsheets API is really not fun to work with. It's pretty horrendous. And the second thing, which was crucial, is that you can't get live notifications of changes in the spreadsheet. So you can register to listen to a spreadsheet change, but you only receive the change after a while. It can be minutes, or it can never, you can even never get it. So that would lose that fun feeling we just saw in the demo. So I had to build the server as well. And I immediately thought about building it this way. So we have the native. On one side, we have a server, and they communicate via Websockets, and also a web application that communicates to the server with Websockets as well. And the reason I chose Websockets is it's widely known. It's supported in all the languages I care about. Browsers support it. It runs over HTTP, which means if you're behind a firewall or something, it knows how to. If you can access a website via HTTP, you can also open a WebSocket to it. And also, it's very fast, very low latency, so it was a perfect technology for the communication. And I chose to implement the server with Node.js and host it on Heroku for the reason that Heroku had the best tutorial of, they have an example Node.js with WebSocket implementation, example project, and I just took that project and built upon it, and it worked, so I just used it. And also, it was an opportunity for me to learn Node.js, which I didn't really know until then. And speaking of WebSockets, you have vanilla WebSocket, which is 4 functions. You have on open, on close, on error, and on message, where all of your business logic lives on message. So every message received via WebSockets, the function that gets called is on message. And then you have to parse that message and decide which type of message it is, whether you want to act upon it or discard it, or all of your logic is in on message, and you have to do everything. Socket.io, and I assume there are other frameworks as well on top of WebSockets, provides a richer interface like channels and subscriptions, auto reconnect, and custom events. So you can register for an event called on received message from client, or on received request for disconnect, or whatever it is. And it's more, you can tailor it to your needs. But I went with vanilla WebSockets because it was simpler, and because my server is basically just a pipe between the native and the web. So I didn't need a whole lot of functionality out of the WebSockets aside from the communication. How it works. We have the native application and the BetterContent CocoaPod installed. And that CocoaPod runs a scanner every second, scanning all of the UI of the application. And if there are any changes in the UI, it serializes all the UI in the form of a JSON object and sends it to the server. Then the web client receives that JSON, parses it, and then displays it, trying to mirror the appearance from the native on the web, and also provides a way to edit the different elements on screen. In this case, only label, but it could be a picture or whatever. And then once the user of the web client makes a change, modification JSON is sent back to the client, and the client then takes the modified content and applies it at runtime to the application. I'm going to go a little bit deeper into how the native part is written. So there's a timer running each second. I thought it was a reasonable time for the tool. And what it does, it builds a dictionary of all the views in memory, where the memory address of the view is the key, and the view is the object. And the reason I keep the memory address is when I receive the modification JSON from the web client back to the native, the way to identify the view that needs to be changed is by the memory address. And if by the time I receive the change from the server, I can't find the view with the memory address in the table, it means that view is no longer visible, so I just discard the change. There's nothing to do. But if I find it, then I change. There's one important caveat to think about here when you're holding views in an NS dictionary. An NS dictionary holds a strong reference to both the keys and the objects. So that means the reference count of the views will increase by 1 just by putting them in this NS dictionary. And that can mess with the application functionality. Because if you have code in your view controller or in the view that runs in your dealloc method, that means you're relying on the view to be, the reference counts to go to 0, and then the dealloc method gets called, and some functionality happens. But if I hold a strong reference to that view, then the reference count will never go to 0, and that view would never be deallocated, and whatever code you had written in the dealloc method would never get run. So that's really bad, and I didn't want, well, obviously you don't want bad code running in your application. So it's important to hold weak references to the views. So the problem with weak reference is it's just like any other pointer, but once the view is deallocated, then you have a garbage pointer pointing to nothing. And if you try to use it, then your application crashes. So you have to identify when the pointer you're holding to points to nothing anymore. And that's a bunch of boilerplate code. And instead of messing with that, I just used a pod called MA zeroing weak ref, which is a proxy object to whatever object you want to hold. And it returns nil in case your object is no longer in memory, which was perfect for me. And that's how I hold the views. Also, a nifty thing I used, I told you I wanted 0 configuration. So if you're using CocoaPods, then you know to install a pod, it's you add 1 line into your pod spec file. And that's all you need to do to install BetterContent. The way it works is I hooked into the Objective-C runtime sequence. And the runtime sequence, when you launch an application, one of the first things that happen is all the classes gets loaded into memory. And for each class, if the class implements the static, or not the static, but the class load method, then that method gets called. And then you can do stuff in that method. The only thing to remember is that the order in which the classes are loaded is not defined. So if you are referencing another class in your load method, that class might not be loaded yet, and then your application would crash. Fortunately, though, external and shared libraries are guaranteed to load before any custom classes. So the NS Notification Center class is part of the Foundation framework, which is a shared library. And by the time this code runs, I'm guaranteed that the NS Notification Center class has been already loaded, so it's safe to call it this way. And what I do here is I register for the application finished launching event. And then when the application finished launches, the scanner immediately starts to work. The other part of the native implementation is the serializer. So we have the scanner scanning all of the UI and building an NS dictionary of all the views. And then we need to send it to the server. And I wanted that also, that piece of code, the serializer, to be concise and easy to understand and to build for any custom UI class. So I could have written the serializer in some external class which receives the UI view and determines by the view class how to serialize it. But I found this solution a lot more elegant. We have a category class for each UI view you want to serialize. So in this case, we're talking about UI label, and it's the BTC label category. BTC stands for BetterContent. And there are 4 methods you need to implement if you want your view to be serialized to the server. The first is BTC is serializable, and you have to return true. It's obvious. if you have this function and returns true, then we send this the view to the server. If not, we ignore the view. And the reason we need this is we don't want to send all the views to the server. If you ever looked in the views that are present at runtime in your application, then you'd see that Apple adds, or the Objective-C runtime adds a lot of views, intermediary views to your application. So you have a lot of invisible views that you really don't need to send to the server because they don't display anything. The second function is BTC class. This is just a string. And this string is used by the server or by the web client to identify which class it just received. And this is how the server knows how to display the UI on the browser. The next method is BTC attributes. And here you construct a dictionary with all the attributes relevant to the view. So if we're talking about label, then we have text, obviously, and in this case, we have font and color, but we can add also alignment, the name of the font, or all of the attributes of the view class. In case of image, we'd have a base64 encoded version of the image. And the last function doesn't have really to do with serialization. It's just the update with component. This function gets called when we receive the modification JSON back from the server. And now we need to implement the change in runtime. So the UI label knows how to make the changes to itself. So it receives the BetterContent component and parses whatever it needs from it and makes the change at runtime. So that's the native part.
Just a small question. Can you go back? In this example, you can only change the text, not the color or font or...
Right. I only implemented this change. But if I wanted to change the color, for example, I had to find some way to have the web client change the color, maybe with a pop-up dialog on the browser or something, and then serialize the color. And then I'd have two lines here, one to extract the text, and the other to extract the color, and then apply it. Packaging, so I chose CocoaPods because it's so easy and fun. But not all projects use CocoaPods. Some projects don't, and I currently don't support it, but I want to support the ability to install BetterContent with iOS framework. So wrap it in a framework and have projects that don't use CocoaPods use a framework instead if they want to. But this may never be implemented because more and more projects, iOS projects, use CocoaPods because it's just fantastic. And a little bit about the server and then the web client part. And so the server is mainly a pipe between the native and the web. Just a simple WebSocket protocol. I'm going to show you the code in a second. This is, well, I trimmed it down a bit, right? But this is basically this is the code that runs on the server. It's Node.js code. It's JavaScript. And you see here we have a listener on the connection. And once we have a WebSocket connection, then we listen on the message, on message function to get called. This gets called whenever a message is received via the WebSocket. And then I use three different types of messages, the register, ping, and UI. Ping is necessary because I found out that the connection gets broken. So the simplest solution is to just send a ping message every 5 seconds, and that keeps the connection alive. And I don't know if it's the best solution or the right solution, but it just works. So I left it. And the UI is where all the application content and the modification JSON is being sent. So if I receive a UI message from the native part, I send it to the web part. And if I receive from the server, I send to the native.
Is this the same interface for both the web client and the mobile?
Yes. Yes. the code here just says, if you receive the message from the web client, then send it to the native client. It just passes messages back and forth. And the native and the web server are in sync, of course, so they know how to read each other messages. There's no parsing made in the server.
Is there a reason for using WebSocket secured?
Well, yeah, if you want, it's a public server, so just basic security.
So there's no reason, other reason than security, because I know that some servers, some firewalls might filter WebSocket connection unless it's secured.
Well, I haven't really run into that issue. There aren't many users of BetterContent currently, so I haven't received feedback. I mean, that's one reason it's open source, so you can just take and launch your own instance of the server and make it secure and unsecure as you want. There's no, I mean, I just made it secure and left it. I haven't put too much thought in it since, to be sincere. The web client is a bit more sophisticated, and the code that I'm least proud of in the whole BetterContent tool. It's just one big JS file. I did break it down into components. So we have a label component, and we have an image component. And each component is responsible to display the element on screen and also to provide a way to edit. And this is the label component here. And if you remember earlier, the name label is the class name of the UI label Objective-C class. And that maps into this label. So the names have to match. And we have a draw function, which draws the UI on screen. That happens here in the set attributes on element. It receives the attributes and applies them to the DOM element on screen. And then we have the editing part. We add a listener. And for every change, every keystroke that's being made on the web client, a modification JSON is sent to the client, as you saw in the demo. So that's pretty much the tool as it stands now. And I plan to enhance it in the future and add Android support, support for editing images, also other components like text areas, attributed strings. Currently, only simple text is being supported, but if you have attributed string in your application, it would turn into regular text. And whatever I receive feedback from the community, or hopefully someone else would do some of this. Any questions?
For iOS phones, for example, I think that we have like 6 different sizes of iPhones currently. How do you support different sizes and orientation when you transfer to web, for example?
It's a great question. So currently, the web part, we have, I implemented a bezel around the actual content. And this is just hard-coded iPhone 4 bezel. And it doesn't support iPhone any other size currently. Orientation is supported only, I think, in iOS 7, when the orientation is landscape, the coordinates are being switched. So that's not supported as well. You need to mirror the coordinates on the diagonal in order to get all of the UI elements correct on the web. If you just interpret them as is, it looks horrible. It's all vertical text. So that also should be supported, but I haven't implemented that yet. So there are a couple more slides.
Actually, I have another question.
Yeah.
How do you know what is the difference from what's the distance, for example, between an image and the picture? How do you measure the differences? Because you only serialize each time a specific view.
Right.
How do you serialize the relation between
I didn't quite understand.
For example, if there is, I don't know, 2 pixels between an image and a label,
Right.
how do you represent it on the web? How do you know how to reflect it?
So I use the point measurements, points from the device.
Serialized point measurement.
Yeah, on the web. And I didn't show the code, but obviously the frame of the view is also being serialized with every view you send to the server, and that's how the web client knows how to position the elements. So just as they appear on screen, they appear on the web application. Does I satisfy your question? Okay. So as I was building BetterContent, it was to solve a very specific problem of me not wanting to do mundane tasks, just changing text in the application. I wanted to delegate this to other people in the team. But as I was building this, and also I was tackling the problem of how do you manage application content in general in an application? Do you just write all the text in your xib files, or do you write it in code, or do you use strings files? And if so, how do you manage updates? How do you sync the content in your application with the product manager or marketing team? How do they know what is the content in the application? So the way we had it, it's an awful way to do it, but I suppose a lot of companies do it, is have a Word document or some kind of other document with all the content that you should have in your application, and we have screenshots of the initial layout of how the application should look. And then millions upon, well, not millions, right, but a lot of comments from different people on the Word document. And the Word document starts with a revision table that's increasing. And in this case, I think it was revision 37 or something. And this document is never updated, and it's never current, even when it's written. So it's an awful way to sync the content between the management teams and the code running on the device itself. So as I was building BetterContent, I was thinking maybe there's a way to have content management where there's a single source for the content. And this source is used both by the application to display content and also by whatever documentation UI the management needs to use in order to see what content the application has. And this is all in my head right now. It's just an idea, but I want to share it with you about how I think content management can be accomplished. So you'd had something similar to BetterContent installed on your application. And when you run your application the first time, then you go through all the screens in your application, and each screen is being serialized to the server, like we saw. The screen also gets tagged with some kind of name, and so the server saves all of the different screens it received from the client. So the server has screen 1 and screen 2 and all the other screens, and it also knows how to display the screen, and it also has all the content displayed on the screen because it received all the text. And now the server creates, from all of this content it received, the server creates a content document, which is a string file. And the next thing is you take the string file and copy it to your native application. And the next time you run your application, the application identifies the string file and uses it as the source for all of the content. And now you have the content coming from the strings file, which was generated by the server, from the application content itself. And the application also knows to receive updates from the server to the content. And the way the server makes content changes or displays the content is the way I showed you in the demo. You have the screen, a sort of screenshot of all the screens you have in your application. So you have the content and the context. It's not just a big strings file. You actually see the screen, and you change the content on the screen itself and not in the strings file. And the server is responsible for translating back to the strings file and to the application. So that's the kind of vision I have. And maybe in the next iOS application we develop, I'll make this happen. That's it. If anyone has any more questions, I'd be happy to answer. Thank you. You can reach me. And thank you, LivePerson, for hosting. It's been great.